What this means is as we go from the hottest spectral types, that's O, all the way down to M, then spectra of stars are changing dramatically. A-class stars are the ones which have the strongest Balmer lines, and this is H beta, for example, so they will peak here. If you go to the highest temperatures, they will start to be weaker and weaker, and the same thing will go for the lowest temperatures. Physically, this is because you do not have enough atoms with electrons at n equals 2, and therefore you do not see Balmer lines in absorption. Something else that's really important to point out is all these spectra have been normalized. Otherwise, we would only see the O-type stars. That's because they're the hottest, and therefore a luminosity with a T to the power 4 would outshine everything else. They've been normalized, but you can still see sort of Wien's law running from the peak being towards the ultraviolet and then shifting all the way to the red for the coldest stars. So even though they've been normalized to peak, you can still see that M-class stars are the reddest, where the light is becoming more intense towards the red, and there's almost no flux in the blue. While if you move to the hottest types, the stars will be very bright in the blue. In addition to that, what happens is as you go to colder and colder types, especially for K and M types, there's lots of absorption features that sometimes come from even molecules. And that is because they are cold enough for some molecules to actually exist at the surface of those stars. The other important thing to point out is that spectral class has nothing to do with chemistry. It's only to do with temperature. And therefore, you can actually have an F-class star that is very metal poor, meaning it has very little heavy elements, having very little absorption lines apart from, for example, the Balmer lines, which have to do with hydrogen. And this means that for a fixed spectral type that only depends on the temperature, then the lines corresponding to heavy elements may be stronger for stars that are more metal rich and may be weaker for stars that are more metal poor. If you look at spectra in terms of flux density versus wavelength, this is how they rank. If you start with O-class stars, they will look incredibly blue. The peak from Wien's law will be beyond the blue all the way into the ultraviolet, so you don't even see it here. And there will be very little absorption lines. They will be very weak. That is because essentially all the hydrogen has been ionized. You no longer see that. And for helium, some atoms are still singly ionized, while many will be even doubly ionized. And therefore, there will be very weak features. Because O-class stars, especially the hottest, have very little features, they're actually one of the prime sources for calibrating spectra, because they provide something that's very nice and featureless. As you go down in temperature and move from O-class stars to B-class stars, what you'll see is Balmer lines become stronger and stronger and stronger until you get to A-class stars around here, which will have the strongest Balmer lines. And you'll notice that also the peak of the black body emission is shifting towards the red as we move into G-class stars, but also as we move from A-class stars to F, we'll see that these Balmer lines, and you can focus on this one, for example, is becoming weaker and weaker. This system is formally called the Harvard Stellar Classification System from OBAFGKM. And you also have access, both in your lecture notes and in this video, to this summary table that will tell you about the main spectral features of each spectral type, and also a guideline for the surface temperatures and how spectral types are defined in a quantitative way. O-type stars will be those with temperatures in excess of 30,000 Kelvin. They're the bluest stars. And then as you move down, you'll be going to the lowest temperatures of something like 2000 Kelvin, where stars will look the reddest. And you'll find absorption lines from even some molecules and from neutral metal atoms. While if you go up, most absorption lines will be from ionized elements. If you're wondering, our sun is actually a G-class star. It will be here. It's a G2 class star, and it has quite strong calcium H and K lines, or basically lines of singly ionized calcium. It's important to point out that you should know the broad features of these spectral classes and roughly how they rank, whether a star should look relatively red or blue, but you don't need to memorize or know all the details. And if you have questions, please just get in touch.